Good day to you. I would like to present you an article on Electrospark method of obtaining metal nanoparticles for the creation of antifungal drugs, fungicides. I have written this article together with three authors: Konstantyn Lopatko, Oksana Zazymko, Kateryna Vynarchuk, and Tugay. In our article, we introduced a method to solve the issue of biosafety and ecology in agro-industrial sector. We as authors have substantiated the biological functionality and efficiency of the use of colloidal forms of metals. It should be noted that the abolition and significant reduction of the rates of application of traditional agrochemicals into soil, including basic mineral fertilizers, gives the ability to controllably influence the functional self-regulation of plants under the influence of biological active agents, which are metal particles. The analysis of works in which the effect of substance on biological object was studied, as you can see in the diagram, there is biological functionality of nanoparticles of metal, allows us to define the functionality of the substance as a complex concept based primarily on its biological or physiological availability. At the same time, soluble forms at high expansion rates and low concentrations have exclusively transit function, but at increased doses, such substances can cause acute toxicity, even if they are and existing cations are removed from the body. They will still be a source of cautions and metal nanoparticles for a long time, and this need to be solved. That is what we address in this research. Besides, it is obvious that biological functionality of nanoparticles will be related to their morphological characteristics and accordingly to the parameters and conditions of the synthesis. So in this diagram, we'll see all the main components and parts of biological functionality that have been studied and modeled. And to solve the issue mentioned before, we used a special device which consists of three parts. There is a generator of discharge impulses, there is a discharge box, and block of control of discharge parameters, which is used to control. We use the granule layer of metals under influence of plasma channels heated to temperature of 10 to 4 Kelvin. And as a result, we obtained 7 concentration in colloidal solution for 7 different types of metal, ranging from zinc to ferrum to argentum to magni and others. In order to better illustrate this process, let's look at technological complex for obtaining metal nanoparticles. This device consists of 8 parts, and the process goes as follows. The device starts with metal granules, which are number 4, are loaded into a discharge chamber, which is pointed number 1, formulating a conductive layer, number 5. The discharge chamber is filled with distilled water, occupying from 1/3 to 2/3 of its volume. The compressor 3 is turned on, supplying air through the sprayer 2 into the chamber. Afterwards, the discharge pulse generator is activated, delivering electrical impulses to the electrodes. At this moment, short-lived plasma channels form between granules, initiating the process of electrical erosion of the metal granules. As a result, we get a product of electrical erosion that includes the formation of colloidal fraction of metal particles and microfractions. So to sum it up, this device consists of 3 main parts. There is a discharge pulse generator, compressor, and a discharge chamber, which is filled with water. And we use plasma discharge to seal the solution. In most cases, what we receive is metal particles. and metal particles have a compact shape and narrow size distribution. As for their general morphology, it should be noted that their average size ranges from 20 to 30 nanometers. And individual particles can have amorphous state at the sizes of up to 10 nanometers. At this slide, we see 2 out of 7 metal particles that we studied, namely argentum and cuprum. It should be noted that most copper and silver particles, which sizes from 30 nanometers, are polycrystalline with pronounced morphological characteristic of solid phase. In addition, oxygen atom and molecule are absorbed on the surface of the particles. As a result, the general structure of colloidal particles is a metallic core and an oxide shell on the surface. You can see this on the screen. As a result of electrospark treatment of the granules, we get a formation of nano-size fraction of corresponding metals, namely argentum and cuprum, which are colloidal form and of sufficient concentration, ranging from 100 to 1000 ppm for microbiological research. On this diagram, you can see 2 types of metal with different treatment using control in PNP solutions and the resulting substance. On the bottom, there is a graph that illustrates the survival microscopic fungi. 2 types of fungi in action for PNM, argentum and cuprum expressed in percentage to control. You can see control and PNP, this type. As a result of our research, we found out that the inhibition of the germinated conidia of micromycetes was up to 97% in relation to control. The test result indicate that the particle nature of matter PNM solution prepared based on argentum and cuprum at a concentration of 9 microgram per liter are effective fungicide agents for Penicillium sp and Alternaria alternatum. Another important conclusion is that the use of PNP can help us solve the problem of using highly toxic chemicals, fungicides, and biocides. And it enables us such solutions to inhibit the growth of pathogenic microorganisms by almost 100%. So these solutions are non-toxic to a biological system and have prolonged effect. So which means that they can be used in practice and have a good prolonged effect on the environment and help us solve existing issue. Thank you for your attention. I'll be glad to answer any questions that you might have.